As you can see, I have a lot of mousetraps down there inside this plastic box, right?
Mm-hmm, quite a few.
Yeah, well, as a matter of fact, there's 8 rows times 12, so how many is that?
96.
90, and on each mousetrap, what do you see?
2 ping pong balls.
Yes, because this is a sort of a very famous demonstration that many people have seen, and it's a lot of fun to do, that illustrates a chain reaction. Do you know what that is?
Well, I've heard of it. I think it's a reaction where one object sets off a group of other objects.
Like what?
Well, dominoes?
Yes, you could have 2 dominoes and then 4 and then so forth.
Mm-hmm.
Well, this has to do with radioactivity. In fact, this takes place inside a nuclear reactor in which they get one particle, which is this ping pong ball right here, and they drop it. In this case, there's a hole under that piece of paper.
All right.
You're going to drop it in there. That will now set off at least one mousetrap. Okay, now what will happen then to the 2 ping pong balls that are on that mousetrap?
They will set off 2 each.
Right,
and
they'll
it'll
fly
keep
out
on
in
going.
front of 2 more. Now, it doesn't always work. Not all of the mousetraps will go, because not all of the energy necessarily hits the atom in exactly the right place.
Okay, so sometimes the ping pong
Sometimes,
balls miss.
right.
Okay.
Anyway, and in a nuclear power plant, they have all kinds of very technical ways of controlling how much of the reaction takes place.
Okay.
But in our case, we're just going to let it go. So
All
are
right.
you ready to set off a chain reaction?
Sure am.
Okay, there's your first particle. I'll move the paper out of the way where the hole is, and you drop in the first one.
All right. Now there is a chain reaction.
Right. This common mystery object is the top of a plant you no doubt have eaten. One of the buds has been opened up, so you can see some of the parts inside. Eventually, the parts would have grown into many fine branches that make the mature plant resemble a fern. Long before that can happen, the young shoots are harvested and end up on your plate as asparagus.
Well, that there looks like the inside of a big machine or something.
With gears clonking away?
Uh-huh.
Well, as you know, you saw me set it here on this little stand. It's actually an old alarm clock mechanism.
It is?
Yeah, and we're making it look like that because we're magnifying it. See, here I have the little alarm clock mechanism sitting right there.
Uh-huh.
Lights shine on it. The image now is picked up by this lens, goes through my little television camera, and up over there to the television screen. So it only looks like a huge machine, but is really a plain old clock. And the reason I wanted to suggest that you take a look at things like this, Michael, is most people don't realize what fascinating things they can find if they just look at the world magnified 10 times. Just go around, look all around the house, outside. Well, and it not only big, but you'll find all kinds of detail that you wouldn't have noticed unless you magnify it. And the magnifiers that you want to use are something like this. Here's a jeweler's loop, you know, the type they put on their eye. That magnifies about 12 times and is one of my favorites. Then here's another type that has 2 or 3 lenses that you can put together. So if you put 1, you get about 5 times. This is about 10. That may be about 15. So you can look at. So you want to look at things around, and don't hesitate to look at almost anything. Even old weeds look very interesting. Let's make sure, though, that you understand sort of what we're doing when we say we're magnifying 10 times. What is the width of the television set up there?
Well, about 15 centimeters.
Yeah, 150 millimeters.
Yeah.
Okay. Now I'll put a little ruler here in front of the television set so that we can see how much of that ruler.
Wow.
Now there is millimeters again. You can see it starting here at 8, and how many millimeters?
15 millimeters.
15 millimeters. Okay, so if we're taking 15 millimeters and we're magnifying it up to 150 millimeters, so how much are we magnifying?
10 times.
10 times, right. And of course it depends on the size of the television set. If you had a big one.
Well, that would make a difference because it's a bigger screen.
Bigger screen, right. But for our purposes here, you'll get a good idea of the fascinating things you can see when you're magnifying 10 times by putting them under my little microscope. Then, after the bird has sat on the nest and you're sure that they're not coming back, take a look at birds' nests because you can find out a great deal about the bird by just looking at the nest. And here is
what kind of a nest is that?
That is a hummingbird's nest.
It's so small.
Yes, well, a hummingbird is a small bird, right?
Uh-huh.
Let's take a look at what you can see when you look at a hummingbird's nest magnified 10
Oh,
times.
wow. That looks like it's made out of grass or something.
Yeah, they have grass and little seeds, you know, that blow in the wind. And the important thing, I think, is, as far as I'm concerned, the most fascinating thing is that she weaves it all together with spider webs.
Oh, yeah, you can see that.
See the little spider webs? And here's the inside of the nest where the eggs would be. And as you know, the eggs are about the size of a pea. So there's what is...
It looks like a big nest now.
Yeah, doesn't it? Well, that's what a hummingbird's nest looked like magnified 10 times. Then, of course, insects are always fun to look at. And you can catch them, put them in a little box and look at them while they're alive or have them preserved. And here is one of my favorite specimens.
Gross.
It is a gross? No, it's a grasshopper. And there's what its leg looks like, magnified 10 times.
And there's little pricklies on,
yeah, little
on his leg or
pricklies all over
something.
it so we can crawl on things, obviously. Now let's go up the leg and see the legs to also have those little prickly things, see it?
There's his wing.
Yeah, there's the wing. And now, have you ever looked a grasshopper right in the eye?
No.
Well, you're going to have an opportunity, because here,
yuck.
here is the head of a grasshopper staring
It's
you
huge.
right in the face. Marvelous detail, though, isn't it, on some of these little animals? All of which you can see when you magnify it 10 times. Now, do you drink coffee?
Well, sometimes.
Sometimes. You put sugar in it?
Uh-huh.
Well, then what you should do is get a little container and put some sugar in the little container, like that, and then going to have you add some water. Here.
Okay.
You stand by with that, and I'll get this in position, and you'll watch what happens when you see sugar dissolving, magnified 10 times. Don't put it on top, put it on the side, there, all the way. Okay, there are bubbles.
Uh-huh.
Okay, now watch. Put in a little more water, Michael.
Okay. Well, you can see some kind of like fumes in the water, sort of.
Yeah, they look like fumes. Well, obviously, when the sugar dissolves in the water, it's more dense than the water itself. So that's why you can see the different density. See, it looks like it's streaming.
Or gas and water, sort of.
Yeah.
That kind of looks like a great big iceberg.
Doesn't it, though?
Oh.
Ooh, things are falling down on the backside, so watch it. It looks like those pictures you see of the end of a glacier breaking off and falling into the water.
There it goes.
There it goes.
That's neat.
Well, thank you. So you see, even a lump of sugar dissolving in water can be a fascinating thing to watch,
Yeah.
as is the rest of the world when you magnify it about 10 times.
There it goes.
There it goes.
That's neat.
Well, thank you. Chris, have you ever used a rangefinder in a camera?
No.
Well, someday you'll get one, and what it amounts to is you look through the viewfinder and you see two images, and when you can get them both lined up like that, that means the camera is focused at the right distance. And that's what we're going to be doing here today. This piece of wood here is a rangefinder, meaning it's a method for finding how far away something is. And first of all, what I'd like you to do is you look down this black line and you line up the object above this mirror. See, like I have a white stick out there, you'll put the white stick over here.
Well, what is this for?
Okay, then there's another mirror over here, and this one moves. See how it moves?
Okay, yeah.
Well, the image of that stick is going to be reflected in this mirror, over to this mirror, and over to your eye. So you line it up, you move this stick back and forth until you see the bottom part of that white stick, and it's lined up exactly with the top. Got the idea?
Okay,
Okay,
yeah.
try it. First, look down the black line until you see the white stick
That one?
right above,
there?
that one right there.
Okay. Okay, so
Okay,
I just
now-
have to move this?
Right, just move that now until you can see the bottom part of the stick in the mirror right here.
Okay. Okay, there it is.
Like that?
Okay, yeah.
They're both lined up.
Yeah, they're both lined up.
Okay,
so,
now I put that white stick purposely at 5 meters. So you write 5 down opposite there.
Okay, fine.
Okay? Now you see way out there, there's a tree with a red tape that I put on it.
Okay.
Try the same thing with that.
Okay.
So I just have to put this under.
Put the red mark with the red tree right there, and now move that stick. And tell me what you see.
Okay. I can't see. Okay, I can see the tree now.
Coming in?
Yeah. Okay, it's lined up with the top half.
Okay. I measured that, and that's 30 meters, so you can put 30 down there.
Okay. Here?
Mm-hmm.
Okay.
Right opposite the pointer.
Okay.
Now, see that stick right there?
Yeah.
Line up that skinny stick
With the black line
with
in
the
the mirror?
black line, and tell me how far away that is.
Okay. Okay, there's the pole.
Okay, I put that one exactly 10 meters away. So you can write 10 there.
Okay. Right there?
Right there.
Okay.
Now, you see there's a tree out there with black tape on it?
Okay, yeah.
You're going to have to tell me how far away that one is.
Okay.
I better try this.
What are you doing now?
Okay. So the black line is right under the tree.
Right over there. Okay.
So I just got to match the bottom half with the top half. Okay. Okay.
Got it all lined up?
Okay, yeah.
Here's 5 meters. There's 10 meters. There's 30 meters. Where do you think the pointer is?
Okay.
20?
20 meters, yes. I measured it, and that's it exactly. And notice, by the
Okay.
way, the further out we got, the smaller and the closer and closer the marks would be.
Okay, so if there was a tree way out there.
Right there, it would hardly move up here at all.
Okay, so you just have to push this
Way like that.
way forward.
And notice, by the way, that this is much more accurate when the distances are nearer, because the angle of that mirror out there changes much more dramatically.
Okay.
Well, you've never used a rangefinder, but now you have. You are an official rangefinder.
Thank you very much.
You're welcome. Here are some safety glasses, Jackie. I'd like you to put them on.
Okay.
Have you ever worn safety glasses?
Yeah, when my dad was welding at his shop and I came to look at them.
And so you put it on so that
Yeah,
nothing
so
can
my
get in your
eye-
eyes.
yeah.
Well, I'm going to put them on too, because you and I are going to do a dangerous experiment. Here are 6 corsage pins.
Okay.
And here is a balloon with 5 patches of transparent tape on it.
Okay.
I'd like you to take one of the pins and stick it right there in that patch.
Any one of
Will
them?
it break?
No,
Well, how do you know?
because the tape sticks to the pin, and so none of the air can leak out.
Okay, have you tried this?
Yeah.
Okay, so you say that it's not going to break because the pin is going to fill up the hole, in effect.
Yeah.
Well, another thing is, the tape also prevents the rubber from tearing. And in order for the balloon to break, it's got to tear.
Yeah.
So there's 2 things.
Yeah.
Okay, put the first pin in.
Okay, anywhere?
Anywhere you like. Aha, number 1.
Didn't even pop. Okay, now I'll try this one.
2,
That one. Okay.
3,
Oh, wow.
4, 5.
Wow, none of them popped.
6th pin.
Yeah, what are we gonna
Obviously,
do
you
with
have
this?
no more pieces of tape to put in. What'll happen when you put this one in, say right there?
It'll pop
Why?
because it'll rip.
Yeah, the balloon can rip.
Yeah.
And now you can see why I suggested we put on safety glasses?
Yes.
Okay, here you go. Very good.
It works.
Yes. These men are robbing eggs from one of the rarest birds in the world in order to save them. Hopefully, the eggs will hatch into whooping cranes, birds that were common in Canada and the United States in the 1800s. They're the tallest birds in North America, and their name, whooper, comes from their bugle-like call. Once, they nested in the marshes of Northwest Territories and flew south to winter in southern Texas. However, as civilization moved closer to where they lived, the cranes dwindled to only 15 birds in all the world by 1941. It looked as though whooping cranes were going to become extinct unless something was done to save them. A male and a female were put into separate but adjoining quarters at the U.S. Fish and Wildlife Service's Patuxent Research Center near Washington, D.C. Their food and living conditions duplicated what they would find in the wild. The whoopers courted with their typical mating dance. It seemed that success was on its way, but no fertilized eggs were produced. So the female was artificially inseminated with sperm from the male, a common procedure for breeding farm animals. And it worked. The female produced fertile eggs. In the wild, a whooper hen lays only 2 eggs each year. With artificial insemination, she produced 14 each year. But there weren't enough whooping cranes to hatch all the eggs. So some of the eggs were placed in the nest of a sandhill crane. She hatched and raised the whooper chicks as though they were her own. Whooper chicks learned to survive from their parents, in this case, their foster parents. Eggs have also been taken from the research center to a wildlife preserve in Idaho, where they were placed in the nests of sandhill cranes. The whooper eggs hatched and the chicks were raised by their wild foster parents. So the white whooper, here flying with sandhills, is making a comeback because scientists robbed eggs from the whooper's nests and the chicks were raised by foster parents. Have you ever poured 2 fluids at the same time, Christian?
I suppose when you have one fluid and the other fluid and you pour them both at the same time.
No. I mean with one hand, like this one. Try this.
Okay.
Go ahead. Pour the water into the sink.
That's just one fluid.
There are 2. What does the word fluid mean?
I always thought it meant a liquid.
Fluid means it flows.
Oh.
Anything that flows is a fluid.
So air could be a fluid.
Air is a fluid because it moves all around. Okay, so now you're pouring 2 fluids at the same time, right?
Right, you're pouring the water, liquid fluid,
Fluid's going down.
and the air or gas fluid
is coming up.
goes in there.
Right. So today you and I are going to do a whole series of experiments with those 2 kinds of fluids. First one, air, because that's easiest. Come on over here. I have a vacuum cleaner all rigged up. Here's the hose, and in the end of it I have a cork with a hole in it, see? Make it so it reduces or increases the pressure. And as you can see, I have it in the blower end, right? Okay. Now, I'm going to hold it over the top of this tube, and I want you to describe what happens. Tell me what happens.
The water
Well, let
is
me turn
going
the
up
vacuum
the
cleaner.
tube.
Hold a minute. What happened?
The water is going up the tube.
Okay, now the reason why it went up the tube is based on a principle that a scientist developed. His name was Mr. Bernoulli. And he discovered that there are 2 kinds of pressure in a fluid, anything that flows. One is dynamic pressure, that's when I blew the air against you. And the other is the static pressure, that's the pressure going all inside the fluid. And he found that the greater the dynamic pressure, the lower the static pressure. So if you can speed up the fluid, you'll lower the pressure on the inside. Okay, now what happened when I blew across the top of this tube? I increased the dynamic pressure going across here, so what happened to the static pressure in the tube?
It decreased.
Right. Outside air pressure pushed down on the top of the water,
Which
made it come up. Okay, here we go again. Let me try it this way, watch. Getcha? You felt the little fog coming off of there? Get some on your glasses? The reason I wanted to do that is because you've probably seen somebody do it like that, haven't you?
That's,
you know what?
It's atomizer?
Atomizer, right. And now you should be able to explain how it works. So the same idea as this glass in the tube.
Okay, so this tube would be the same as that white tube inside.
Right.
And there's the water. And this would be the same as this.
Right.
So that the pressure, the air.
The dynamic pressure on top of that tube must be lowered, right?
Yeah.
And if you look closely at the top of an atomizer, you'll find a little hole that lets outside air pressure come in here like that.
Which makes it go up.
Right. Later on, we're going to do the same thing with a liquid fluid. Okay, then you see these 2 cans over here?
Yeah.
Okay. We turn them on their side like this. And most people would suspect that if they were about that far apart and you blew air between them, which way would the cans go?
They'd separate.
Okay, try it. Here comes the...
Hey, they came together.
Okay, now why?
Because the dynamic pressure
Yeah.
decrease the static
pressure in here.
which made them come.
And the outside air pressure pushed them together. Right, that's the idea. Well, now that you understand the dynamic and static pressure, let's use the same principle to do some things that are sort of more exciting. Come on over here. Kind of like magic, as a matter of fact. You hold the end of the vacuum cleaner like that, and hold the balloon in the other hand.
Okay.
I'll turn it on. And what's holding the balloon out?
The dynamic pressure.
Pushing against it like that. Okay, now I'm going to take a scissors and cut the string, and you watch what happens.
It's still staying mainly in the same spot.
Oh yeah, why?
Because
You're right, dynamic pressure is holding it up.
so the dynamic pressure is going around it to keep it in the same spot.
Well, as the dynamic pressure goes around the end of the balloon here, it lowers the pressure right there because the static member inside the stream, so the outside air pressure is keeping it here centered so it doesn't fall off on one side or the other. Okay, you hold on to the vacuum cleaner, and I'm going to grab the balloon. You can also do it, let's try this. Here, take hold of the ping pong ball and just put it on the top of the stream and sort of let go when you feel it sort of, there you go. Magic.
Hey, it looks like magic.
Isn't it? And if you're real careful.
That looks really neat.
Yeah. So this is a popular demonstration in science clubs and so forth, and in vacuum cleaner stores too. They sometimes have this. Then, try this one. Here, take that one and put it up there and let go.
Hey.
Okay, now you can begin to move it sideways just a little bit. Why is the ball spinning?
I suppose because the dynamic pressure is more on this side, so it's kind of making it spin a little bit.
And yet there's enough static pressure to keep it keep it going there. Okay, so now we've had fun doing it with a fluid called air.
Air, yeah.
Let's do the same sort of thing with a fluid called water. We got to go out in the backyard. Come on. This time our fluids are going to be liquids.
Hey, that looks like the atomizer we had
Yeah.
in the kitchen.
Okay, how does it work?
Well, I suppose when you push this, the dynamic fluid, which is I think, water, will come through here, and then the static pressure in here will be lowered, so that this fluid in here will be able to go through the tube and out.
You use this to spray for insects or fertilizers.
Yeah.
Okay, try it.
Okay.
Okay, very good. Now, Kristen, I'd like you to turn off the water, change hoses, and then turn it back on again, okay? Then come back. See it over there? Okay, what does this correspond to, Kristen?
That could be the same as the vacuum cleaner with the air fluid.
Only now it's a liquid fluid. So you know what to do with the ball.
Okay.
Get it up there and top if you can. Great.
There we go.
Yeah. Be fun on a hot summer day, right? You can have
It's
kids
really
playing
fun.
around. Okay, I'm going to grab the ball and watch what happens when you put a balloon on.
Look at it, it's spinning around.
Right. So you can have a lot of fun with fluids, right?
Yeah.